Hey everybody, welcome back to the channel. Today we are beginning the electrical wiring for the ATC project. I'm standing on the back side of the machine with my access to the electrical panel in there. And what we're doing to start out first is we're going to set up the step down, the buck converter, to step down the 72 volts from the machine to be able to be usable for our ATC. So I've already kind of went through it a little bit. When you come to your back of your machine, your ATC plug is right here. When you look at it from the inside, it's from right there. Alright, in the drawing, it shows 204 and 205 as being the ATC voltages. 205 being the positive, which is the brown lead, and the blue lead is the negative. So here is my buck converter. It's taken out of the case, and I have it set up on a meter. This is the adjustment pot for adjusting the voltage. I have it set up with some pins pushed into the sockets. Now, I have experience with these, with connectors. So make sure you just don't shove anything in those holes. You stretch out those connectors and you'll be in a bad position. When you try to plug something in, you'll get a cold joint. So these pins are barely even enough to make contact in there, but it's enough to be able to set the voltage because there's no load on this buck converter. So I have my orange coming in as my positive. Now the color of the wires don't match those colors. As far as this, pay attention. What positive is positive, what negative is negative. Never mind what color of the wire. So anyways, I have my orange is my positive and my brown is my negative, which inside there the brown is positive. So, and then on the output side, it didn't matter. I just hooked it up to my meter, and you can see I have 24 volts. Basically, you dial this pot until you get the voltage that you need. Alright, here we are at my bench. Sorry, it's trying to get everything in one screen is proven to be difficult when it comes to a GoPro. Anyways, we'll start off with some of the tools that I need. A pair of strippers, a pair of wire cutters or side cutters. This is a terminal assortment. I use these a lot in my motorcycles, and it requires a special crimper. You can get these on eBay and Amazon. This is kind of what it looks like, and this would be the crimpers. You can see it's kind of square, and they come in an assortment of sizes. For this one, we'll be using mostly the white, maybe up to the red. As far as the crimps, they're very small. They're like little barrels. And then you just poke the wire through the back side, and then you put the barrel into the crimp, smash, done. Very nice, gives you a clean look. I do have an assortment of heat shrink for those parts that we need. This Harbor Freight special. You get these. You're gonna need some small screwdrivers, a bigger screwdriver if needed, and a soldering iron. This one happens to be a 35 watt Weller. I use this one a lot. And we're going to need all the wires, connectors, all that good jazz. So I've already taken the liberty and put the buck converter back onto the plate that goes inside the box. These are the wires that came with my stepper driver and motor, and we're not going to use these. We're going to self-wire them. I also have an assortment of wire. So this is Ethernet wire, Cat 5, Cat 6, mainly used for signals. I use it a lot. So basically you just cut the ends off. You can get this in really long lengths. You probably have this stuff laying around your house. I use this for signal, moving from one point to another, so we'll be using that wire for sure. I happen to have this. This is a 4-conductor wire, and it's just automation wire, and I happen to have a 4-pin connector on it. So I'm going to be using this for my air solenoids. So we'll be wiring this in and then split it up to these caps that go on the air solenoids. Finally, the wire for where we just tested the buck converter, the plug, I already ordered this through McMaster-Card. This is a 16.5 cable. I got this McMaster-Card. You get it as I think it was like $1.99 a foot, and minimum was 10 feet, which is more than enough. So we'll be using this to run from our connector that plugs into that socket, and then running it to the box to power the machine. And it also has the conductor for the VFD for future. So that's basically the wire. Oh, and then I do happen to have some of this. This is 20 gauge wire, an assortment. I don't buy cheap wire. I buy really nice automotive grade wire. It handles the heat shrink. It handles the soldering iron. You know you got cheap wire if you go to solder something and the insulation on the wire starts to melt or pull back. Really good quality wire, when you heat it up with the soldering iron, it's not going to pull back, it's not going to melt. So make sure you use good quality wire when you want to do a wiring project. Anyways, so at this point I have this stripped off, and we're going to start do this in segments, and I'll most likely leave extra wire hanging out. We end up wasting some of it. I'm just going to leave extra, and then so that way I can connect it to the actual connectors that go on it. So as I do segments, I'll pause the video, do another segment, pause the video, do another segment, and then kind of recap over what we've done to keep this video in a reasonable length. Anyway, so let me stop here and we'll move on to the first item. All right, we are back. So what we have done now is wired up the buck converter. We had a 4-terminal strip, and all I did was the power output. I jumpered it over on this side for the positive and the negative, and then we have positive and negative that comes back because the system is 24 volts for the stepper driver. So 24 volts here, and then these 2 leads go up to the 24 volts in on the actual interface board. And in the spirit of things, I stuck with the colors of the wiring coming from the ATC, simply because that way it's easier to transition if we're troubleshooting. So not that it's a big deal, but anyways, that's what I've done. And this was done with 16 gauge wire with standard crimp-on terminals here, and of course the terminal block type barrel connectors for there. Okay, what we've done is we've connected the 24 volts to the in from our terminal block here when we mounted the board back onto the plate, and then we have connected the carousel sensors. So we have the carousel and the home sensor, because those cables are going to get routed underneath, and we applied labels onto the cables. This is just extra cut off of the actual sensors because the cables are so long, so we might as well use the extra for wiring the sensors up. All right, here we are. We have another function added to the system. We have added the 5-volt in to the step driver. On my board I labeled it as step and direction, which is the most common of what I've seen over the years messing with CNC. But on this driver, it's called pull. So pull and direction. So what happens is the 5-volt comes in and goes to the pull positive and jumpers over to the direction positive, and then the 2 step and direction signals, so green being the pull negative and the direction being the direction negative. That's how this is wired up. And then this has got to be, this is the UART, that USB. So in the box I have a double-sided female USB. So this gets mounted in the box, and then it'll plug in on the inside of the box, and then this will be outside for the outside of the box. All right, what I've done is I went ahead and I call it beavered out. My step drill was not in the greatest of trying to cut nice smooth holes in here, so I beavered it out. And I have all my pins on both sides. This is the USB plug. I've oriented the USB plug so when the UART is plugged in, there's two LEDs for transmit and receive on the UART, and it'll be plugged facing the door so that if I need to reference it, I can reference it. So at this point, all I have to do is I put the assembly inside the box so that way I can measure the length of wire that I need to go, because I have to hook them up to the connectors first and then run the connector in and then tie it in to the actual box or to the interface board or to the actual stepper driver. All right, what we've done now is soldered on the DB connector. The standard system comes with a DB connector on an extension cord, and I didn't need to use that extension cord, so I cut a chunk off of the wire so I could wire up this connector. So if you've never wired up a DB connector, this is a DB15. Basically, it's a VGA, like a monitor cable or connector, but it's a DB15. When you look at it from this side, the plug-in side, pin 1's the top right corner, and it counts to 5 to the left. Then it's number 6 through 10, 6 is over here, and then 10 counts this way. So 1 through 5, 6 through 10, and then 11 through 15. But when you're on the back side, it's pin 1 through 5 and then backwards. So, and if you have to solder any wires to the middle row, you want to do those first because you won't be able to get to them. So you work from the middle outward on that, and a set of fingers, extra fingers, helps dramatically with doing this. So this is a shielded cable, so I took the shielding and crimped on a connector, an eye connector. So, and I had to cut the edges off because I'm going to tie it to the side of, I'm going to screw it down to the chassis ground. So anyways, this cable's done. We'll get this bolted in place and plugged in and properly terminate the end with the barrel lugs. All right, I have put the connectors on here to clean this up. I also crimped a lug on here because that's just the shielding ground, and I polished off the paint on the back side of the driver, so when this plugs in I can put an M3 screw in there to tighten that down before I install this, but I can't put it on yet. So this is done. So now we'll move on to the 4-pin. I chose to do the DB first because it's probably the hardest out of all of them to do, and it has actual little nuts, because these are threaded standoffs for the screws to tighten the connector on. And putting the little nut on the bottom side was a little bit of a bear, but not terrible. All right, we now have the 4-pin in. The 4-pin goes also from the motor to the stepper driver. And in case you guys, I forgot to mention this earlier, but don't throw away your bags if you use Stepper Online, because the pin outs are on the sticker that's on the bag. So you have the 4-pin outs on what color goes to what pin number. And for the DB15 cable, these are the colors that go to those particular pins. So just another tip. So now we're going to move on to the next item, and most likely that will be for the sensors, because I'm wiring the sensors all on this side, because this is the ATC side. So the motor connects here and here, and then the two proximity sensors, one for the carousel and one for the in and out or the home, goes there, and then the push button for the power drawbar connector is right there. So, all right, so now we have all of the connectors connected on here. So from the box, this would be the push button for the power drawbar, the in and out of the ATC proximity sensor, the carousel proximity sensor, this would be for the stepper motor, and then the encoder for the DB connector. I went ahead and removed the circuit board because these will be run underneath and starting to get a little wonky with trying to work it. So I got the connectors taken out. So the remainder is I need to connect the solenoid holes over here. I did cut an extra hole for the future. So we'll have a 4-pin connector coming out, and that will go to the 2 solenoids over here. That'll leave another blank for a 4-pin. I have some caps I can put in here to cap this off, and the other one will be for the other 4-pin for 2 more solenoids for the future. If I decide I want air blast, then I'll add the 4-pin onto there, and I'm going to wire it where it's closer out, so if I'm in the actual machine, I have the room to work to put that on there. And then the last hole is for the 5 leads coming in, and all that's going to do is get put in with a grommet and then tied in, and then 1 connector coming off of that. So that'll be a pigtail coming off and coming into the box to provide the power. All right, I want to make note, the cable that I got, the 5 conductor 16.5 cable that I got, all the wires are the same color with the exception of the chassis ground, but the wires are labeled 1, 2, 3, 4. I went ahead and capped off the other parts that'll for the VFD to set in there, and I went ahead and flagged the positive with some red heat shrink on there because you're not going to be able to see all of it. I'm going to go ahead and get it buttoned up. So I'm going to run these cables, but I wanted to make note of that. All right, we have everything in the box now. So all the connectors are connected, or as far as the wiring is all connected to the connectors. I have my cable coming in. Pardon my mess. It gets a little crowded when you start doing a whole bunch of wiring. So I have a whole extra amount of wire, and I'll cut that down to length once I'm still waiting on the 5-pin connector that goes to the Tormach. I'm hoping tomorrow. So anyways, that is the inside. This is a very small box, very tight. So if you decide to do a project like this and you got fat hands, it's going to be a trick, especially when it comes time to screw the plate down on there, unless you do some modifications. This one I used the original hardware that came with the thing, and I had to use a crow's foot to tighten them up. Luckily they have an O-ring underneath this machine. There's a pocket machined in the nut that O-ring fits in. I'm guessing it's for dampening, but so you don't have to get them Hercules tight. But for the most part, it is done. I did an extra of this thing has a set of header pins on here, and they could pull off pretty easy. So I put a zip tie around the U-art and the header pins to keep it on there. I may break out my hot glue gun and hot glue it in there so that I ain't got to worry about it coming out. For the most part, everything's hooked up and ready to go. All we need to do is put the connectors on the wire side. The motor's already got it. I just need to put the connectors on the proximity sensors and the push button for the power drawbar, and I need to connect the solenoid power connector to go for here, and then other than that, it's ready to install. So I'll get those pins on. I'm not going to cover that in the video simply because I got to do this at the machine itself, or at the ATC itself, because the wires are right there. So anyways, I have to, now that I'm thinking about it, I have to take this back out and bolt this to the column mount, and then put the nuts back on. So yay, I get to do it twice. So anyways, we're going to wrap this video up. This was a wiring. It's basic. It was super simple. You know, the pointers is, you know, connection of the step driver. What else would there be? Yeah, the buck converter. You know, that's one thing. Everything else is pretty simplistic. I mean, the proximity sensors, they tell you what wire is the positive, negative, and which one is the load. And that's on the board. The power in on the board, then the plus and minus for the solenoids. The solenoids that I'm actually using are polarity sensitive, I'm assuming, because it does have an LED inside here. So when it's activated, the LED comes on. So you have to be conscientious of plus and minus on that. Other than that, it was straightforward. So anyways, please like and subscribe, and we will see you on the next video where we have the ATC installed in the machine and we start doing connection and alignment of the ATC. So see you on the next one.